Search of ambiguous cases. Question 1. Determine the number of possible triangles and then solve the given triangle to one decimal place. Angle A equals to 30 degrees, B equals to 10, and side A is 6 units. Now, I would like you to surely watch my videos on ambiguous cases so that you understand what is an ambiguous case, when do we get it, and how to solve for it, right? These questions are for your practice to figure out which case will give us what condition, right? I will do a part of this question and then rest you can finish off. Okay, now here basically what we are trying to see is number of ambiguous cases we decide by comparing the value of A with B of sine A. Now this is what comparison is required to be done. Now in this particular case, what is B of sine A? B is 10 and sine of angle A is 30 degrees, correct? 30 degrees. And side A is given to us as 6. Now 10 of sine 30 you know is half, right? 10 of half, right? 10 of half, which is equals to 5, right? I purposely taken a very special simple case because we don't want real complications here. First you understand and then we can always get to complications, right? So 30 degrees basically is a triangle where the sides are in the ratio of 1 to square root of 3 and this angle is 30 degrees for us, correct? It's a right triangle. Now here you can see sine of 30 degrees is opposite of hypotenuse, which is half. You can also use your calculator and that is recommended for these questions. So as you can see here, what we get here is 6 is for the value of A and 6 is definitely greater than 5. So 6, that means A is greater than B sine A, and therefore we have an ambiguous case and two triangles ABC can be formed. Correct. So that is the conclusion from all this. How will it look like? Let's try to make a rough sketch of the same, right? So we'll make slightly long. This is my 30 degrees, right? And let me just sketch this like this. So we know B sine A, what we are calculating is actually the perpendicular of the altitude of a triangle, right? Now since A is greater than B sine A, that means we have a triangle like this. It is definitely more than that. And then second could be here, right? So second could be a triangle like this. So these are two possible triangles. Let me label them as A, B and C, right? So we'll write them as A is this angle, A is this vertex with angle of 30 degrees, and let's call this as B, and B side opposite will be 10 units, and this is C point, right? So after 10 units we have point C. So A, C are fixed, but B could be either here or here. So the second triangle, let me call that at B dash. Side A is given to us. So these two sides are equal for us and they are 6 units each. Good. Now let's consider the bigger triangle, right? Now the bigger triangle is triangle ABC. Now in this triangle ABC, let's find out what is the angle B. So to find angle B, we can use sine law, right? So if you say sine of B over 10 is equals to sine of 30 over 6, correct? And from here we can say sine of B is equals to 10 over 6 times sine of 30 degrees, correct? Now, so B, angle B is equals to sine inverse of 10 divided by 6 times sine of 30 degrees, which is half. Well, we'll plug in all the values in the calculator and find this angle B, right? So we'll use your calculator. 56.44. So we get this as 56.44, right? Now rounding to one decimal place, we can write this as equal to 56.44 degrees, correct? So let's say this is 56.5 degrees. Now if this is 56.5 degrees, this is an isosceles triangle, that is going to be 56.5 degrees, correct? Now we can find this angle. So that B dash angle will be how much? B dash angle will be 180 degrees minus 56.5 degrees, correct? So that gives us the answer as 180 minus 56.5, which has given us 123.5 degrees. So this is 123.5 degrees, correct? So that is how we can get angle B, right? The two possible angle B's. One is this acute angle, which is 56.5. The other one is this one, right? For the triangle AB dash C, correct? So we found both the angles. Once you find angle B and B dash, you can find angle C. The big angle C will be this much, correct? And so let's try to solve both the triangles. Let's find now angle C for triangle ABC. So which we can do it here itself. Angle C is equals to 180 degrees minus 30 degrees minus 56.5, and that is equals to 93.5 degrees. So we get angle C equals to 93.5 degrees, correct? So that way we have solved the bigger triangle ABC, and we can find side C, which is AB, by using sine law, correct? So we'll find now side C, that is AB, right? So AB over sine of 93.5, this will get an approximate answer now because I rounded it to 5, right? Equals to 6 over sine of 30 degrees, which is half, right? Sine of 30 degrees, correct? So we get AB is equals to sine of 93.5, and this is 6 over sine. So we'll write this as 6 over sine of 30 degrees times sine of 93.5 degrees, and that is equals to 0.97, which is approximately 12 units, correct? So we get that side approximately 12 units for AB, right? So we get that. Now to find the smaller side, which is AB dash, you again follow the same thing, AB dash, but this time the angle C will be smaller angle, correct? Smaller angle. So the C dash, the angle C dash is equals to 180 degrees minus 30 degrees and minus this B dash 123.5, okay? So it is 150 minus 123, which gives us 26.5 degrees. So we'll use this angle here, right? So AB dash over sine of 26.5 is equal to 6 over the side 6 over sine of 30, correct? Sine of 30. So AB dash is equals to 6 over sine of 30, which is half. Let me write half here, times sine of 26.5, right? So that is equals to just 5.354, and we can write this as approximately 5.4 units, right? So that is how we can solve both the triangles, correct? So you have both the angles C and C dash, B and B dash, and the sides capital C, the bigger C dash and the smaller C dash, okay? So that is how the triangles can be solved, okay? So that is the solution. Thank you.